So last time we were here, we began our introduction to algebra. We didn't really do any algebra, so to speak, but we looked at some patterns. And it's leading us somewhere. And you're going to see a little bit of that today, just a peek of where we're going and what we'll be doing. But we're going to continue looking at patterns, so we'll do that first. And so last time we were here, we looked at patterns that all involved numbers. So they gave you numbers and did something to the number, and you were looking for the sequence, right? To see what we could do to decide what were they doing to it. Were they adding 3, etc. Well, today what we're going to do is we're going to be looking at the same kind of idea of finding patterns, but they're going to give us pictures instead of words or instead of numbers, okay? And we're going to concentrate on one where they do the dots. So they're going to be working with dots. And then later we'll move, because you're going to see that images are used a lot to introduce new ideas, right? Because we think better when we think about real objects than abstract numbers, okay? So we'll be using lots of these picture kind of ideas to make sure we have good understanding. So again, we're just going to be looking at some patterns. All right, so what we're going to do today is we're going to look at what are called dot patterns. So the idea here is to get you used to seeing and developing the idea of patterns. Because if you think about it, most of mathematics is a pattern. Even numbers, 2, 4, 6, 8. We know the next number because we know the pattern, right? And so we also know what to do when we're working with mathematical problems because we know the pattern. When addition has a certain pattern, right? You're combining the first number with the second number to get a new total, right? Okay? So learning how to recognize patterns is a really important skill. And so we're going to look at some dot patterns. Now, so look at, for example, here we have our dot pattern, and notice. I wanted to notice a couple of things because this is what I want to see when you're doing these, because we want to make sure that you're staying focused and staying organized. So first of all, notice that when you're talking about dot patterns, obviously it's just dots, right? So how do you know how many dots? Just count them, right? Yeah, excellent. So you're just going to count up the numbers of dots. But also look at what they do here underneath. What are they doing here?
Yeah, because the dots can be easily mixed up. Writing which one is the first kind of pattern, second pattern.
Exactly, right? So you need to know exactly which pattern is which pattern, right? Where one stops and the next one begins, as well as how many there are, etc. So you really need to make sure that they're named. And you're going to see that these names have come into a very big part of establishing the patterns. And look how they name them. They're just first, second, third, fourth, etc. Okay? So we're going through just naming them by the position. The first pattern, second pattern, etc. That part is going to be very important. The next thing I want to show you and I want to point out to you is this little box here. What they've done is they've created a table, right? You're familiar with tables from Microsoft Word, etc. So using the diagrams and then putting in the number of dots. Sometimes just looking at the pictures doesn't give you enough information to really understand what's going on. But if you put it in a table, you go, now I can see what's happening here. So if you look at it, they have the first one. Has how many dots? 2 dots. The second one had 4 dots. Get rid of my markings so you can see there. Had 4 dots. Okay, don't worry about the 2 plus 2. We'll talk about that in a minute, where they got that. The third one had 6 dots. The fourth one had 8 dots, right? So all they did was lay it out in a table so that you can easily see. And so what we've done is we've translated the number of dots into numbers themselves. Okay? And then look at the second part of that. They said 4 is the same as 2 plus 2. Right? Now, why they used 2, because isn't 4 1 plus 3, 2? Couldn't you say 4 plus 0? Right? There are lots of different ways of writing it. Why do you think they chose 2 as the number they're using there? Let's. Who didn't answer a while ago? You.
Because it's 2 dots. So there's 2 lots of dots.
Because the first one is 2 dots, right? And so what we're trying to do is establish a pattern. And usually your pattern is established by doing something to the very first part of it, right? Okay? Good answer. Good. So when you're establishing your pattern, always look at the first diagram in the pattern to kind of give you a clue as what's happening. Now, do I only have to look at one of them and then I know the pattern? No, we need to make sure that it follows throughout the whole pattern. So if you'll see, what they've done is they've broken down 6 as something plus 2 and 8 as something plus 2. I might have done this a little differently. I think that having the 2 first might give you a better idea of the pattern, but it's no big deal. And you'll see why they do the other number first, right? Oops. I guess it would help if I did the right numbers. So they're just rewriting it as that original number plus something, right? And you'll see why in a moment they put the 4 first. Okay? Because our pattern is really that part. So what are we doing to each time we get a new number?
Adding 2 each time?
Yeah, we're adding 2 every time. So if you see, the pattern part of it is the adding 2 part. And that's why they've put it to the side. Now, so when you're finding these patterns, you're going to see that they try to establish the pattern off to the side, right? So then you can see, do I have a consistent pattern all the way down? Yep, it's add 2 every time. Okay? All right. So what we're going to do is we're going to look at ways to organize our work and be able to establish patterns by looking at pictures with dots. Okay? So let's look at some more of these. Look at this one. In this example in the blue box here. This one is actually a pattern that uses more than one type of operation. So remember that you don't only have addition in mathematics. We have addition, what? Subtraction, what? Multiplication, and division. So you could potentially use any of those operations, any one of them, or any 2 of them, or even more. As you move forward, there could be even more patterns. Now, they're going to keep it fairly simple for you right now. Until you get good at something, then you stay with the easier ways, right? But then as we move forward, you'll see that the patterns can become much more complex. Now, so if you look at the pattern that they have here, the first pattern that they have, here's the first one. Whoops, let me change to a pen. There's the first one. How many dots does it have?
3.
So the first one has 3 dots. So all we're doing is just kind of recreating their diagram. Okay. The second one has what? 5 dots. The third one has 7 dots, right? Now what they want you to do is think about what's happening there so that you can recreate the next one. So if I have the first one with the 3 dots, the only difference between the first one and the second one is that they've added some more dots, right? And where did they add those dots? Just off to the side there, right? So these 2 are the new dots. Okay, so they're just extending the pattern. It's not a completely new pattern, they're just extending it. And then the next one adds even more dots. Right? So the next one adds what? 2 more dots, right? So what do you think is going to happen then for the next pattern? We're going to have 2 more. So it'll look something like that. Now mine's a little messy. Y'all are going to do a lot better, okay? All right, and I'm doing them in color so that we can see each one. Okay, let me get another color going on. Of course. Mm-hmm. And so then the next one, 2 more dots, right? So every time we're increasing it by what? 2. Okay? So if I were going to write this pattern, then I could see if it is just increasing by 2. So this number plus 2 would give you this number. So if the first number is 3, the next one is going to be 2 plus 3. The next one would be, what? 4 plus 3. So you're moving down as we go. You could say that the pattern is add 3, right? Now, every time we have a new number, it's going to be something plus 3. But if you look at the numbers above there,
X, Y, Z.
okay,
Because that's geometry.
well, it's just X. How many words start with X?
Like very
Not very many.
Extra.
Yeah, some. There are a few, but how many words start with D? Yeah. So X is just not a very common number, a common letter that you use, so it can stand for anything. So, all right. Okay. So here we go. So we've established our pattern. We couldn't use just plain addition. We knew we couldn't use subtraction. So we couldn't use just plain multiplication. So what ended up being a combination of multiply and add, right? Multiplying by 2. So instead of knowing which diagram number we have here, I can just say, because did it matter what number this was? Did we still get our pattern? Yes. No matter what number you have, that pattern is going to hold true. So let me just get rid of all of that so that we can look at that pattern. So, for example, I can say any number. And what was our pattern? Times what? 2 added 1 will get you a number in this sequence. So look what they want. So let's say we want the 20th number. Okay? So how am I going to do that?
You're going to times 20 by 2 and then add 1.
Exactly. So in place of our n, we're going to put 20 times 2 and add 1. And what's that going to give me, guys? 41. So now we can have a general rule. And this is called algebraic notation here. Okay? And so we're going to talk just a little bit about that. So anytime you replace a number with a letter, that's what algebra is. So many people are afraid to do algebra, right? It seems different, but it's not. You're really just, all it is I don't know what number that is. So instead of writing out some number I don't know, I can just write n. Yeah? And that's all it stands for. It just means some number that you don't have the value for. And one of the ways that's so important is to replace these, like those formulas that we used for the geometry section, right? What is this the formula for?
1/2 of base times height.
Right? But what shape is that the formula for? Anybody remember?
Triangle.
Yeah, that's the area of a triangle. And each one of those letters stands for a specific piece of the puzzle, right? Well, that's algebra. And that's all it is. So you've been doing algebra this whole time, haven't you? Right? This is called evaluating an algebraic expression. So when you just plug in the numbers. Yes? What does A stand for when it's capital A? Remember? It's one of those shapes. Remember, we did 2 types of measurements for this geometry section. Area, there you go. That formula is the formula for area. Excellent. Okay? So what I want to do is I want to just go through and look at a few more of these. Okay? I'm going to give each table a number, and I want you to tell me what the next number in the pattern would be. Okay? All right, so here's our pattern. Don't worry about our area formula. There's our pattern. Okay, so I'm at that front table up there, the birthday table. I want you all to do, 35. Okay, when I write these down, I'll forget. You guys back there, I want you to do the pattern for 42. Okay, you guys here, I want you to do the pattern for 100. Give y'all an easy one, huh? You guys, I want you to do it for 200. Y'all are pretty ambitious, yeah? How about 1,000? Easy, yeah. Okay? All right, go. Remember, here's what we're doing is we're just replacing the unknown number with a number from the pattern. Okay? Those two groups had the worst part. There you go. Yeah. All right. So, everybody got it? So, okay. Well, let's start over here and see what you have. You guys had 35. So, what did y'all get when you did that? 71. Exactly. So, what they did was 35 times 2 plus 1 gives us 70 plus 1, so 71. Okay. How about you guys with 42? What did y'all get? 85. Okay. So they multiplied that times 2, which gives them 84, plus 1 gives them 85. Okay? How about you guys with 100? 201. Excellent. Doubled 100 and added 1 is pretty much what you're doing, isn't it? When you multiply by 2, it's just doubling. 401. Excellent. And in the back? 2001. There you go. All right. There you go. Okay. Excellent. All right. So you see that by having a rule written in what's called general form or that algebraic notation, then you can just fill in the right number and do any number, couldn't you? Which is exactly what we did when we talked about those geometric formulas. Those geometric formulas that we used are algebraic notation, right? You put in the base, you put in the height, you do the math, you get the area. Okay? So you've been in algebra class all along, you just didn't know it. All right, here we go. So let's look at some more. Okay, guys. So sometimes... Hold on. Sorry about that. So sometimes you need to be really organized to be able to see a pattern. Because you don't want to always have to make a chart, but you could make a chart and then work from there. So what we're going to look at in this time is we're going to look at a way to organize the dots into a pattern so that we can see the pattern. All right? So look at what we have here with our dots. So you see that they give you a pattern. The first one, second one, third one, right? And they want you to, and they're going to organize it in some way to make a pattern where you're having the same number over and over and over again. Okay? So if you had this pattern, you could think of it in lots of different ways. If I divided it in half, then it's 2 dots plus what? 2 more dots, right? If I divided it here, it's 1 dot plus 3 more dots, right? So there's lots of ways you can divide it. What you want to do is you want to try to make sure you're dividing it where you're having the most or the biggest number you can possibly get in the group using one line to divide them. So if you look at where they divided it right there, right? So that leaves 3 on one side and what? 1 on the other, okay? And then if you go to the next one, they were able to do the same thing, but this time they have how many groups of 3? Well, 2 groups of 3, right? And then 1 left over. So do you see that they were able to divide it in a way that was evenly so that they were always coming out with some number of 3s, right? And if you have 2 groups of 3, that's the same as saying 2 times 3, right? 3 groups of 3 is the same as saying 3 times 3. And we always have that 1 left over, so plus 1, right? So can you see can anybody see a pattern establishing here? If this is the first one, what number are you starting with? You just have 3 plus 1, right? Okay? Sorry, I answered your question before you had a chance. So this is the second diagram. So what's the pattern? 2 times 3 plus 1. So this one really has a multiplier, even though they're not showing it. What is the multiplier there if they don't show?
1.
Right. So that's the same as 1 times 3 plus 1, isn't it? So the first diagram is 1 times 3 plus 1. The second one is 2 times 3 plus 1. The third one would be 3 times 3 plus 1. Okay? So how could I write that in a general form, an algebraic form, using a letter instead of a number? Sure.
N times 3 plus 1.
There you go. N times 3 plus 1. So then we would be able to use it with any figure, right? We could move on to any figure at all. So what would the 100th one be then? 100 times 3, which is 300, plus 1, so we get 301. Okay? So grouping them is a really easy way of being able to make sure we see patterns and see the patterns. Look at this next one. We have 3 dots and then 2 dots. This time what we're going to do is we're going to divide it out another way. We're going to go sideways the other direction with the line. But we still get 3 dots, but plus what? 2 dots. Right? Then we could do the same thing here. I know my pen is a little bigger. Now we have 2 groups of 3 dots plus 2 more dots. So it doesn't really matter which direction your line is going. Yes? Right, and so then we get a rule, right? Here we go, 3 sets of 3 plus 2 more. So if this was the diagram number, if we replace that with n, that one doesn't have one because it was the first one, right? It would be n times 3 plus 2. Okay? How does that look? Pretty easy because you've worked with patterns before, right? This is the part that we're really focusing on. Being able to write a rule with an unknown in it, right? Pretty much making your own formula, just like the area formulas are for, right? But you're going to be making your own formula. Okay, good.